Section 10.6, Equations of Circles. By the end of this lesson, students should be able to write the equation of a circle. Students should also be able to use the equation of a circle and its graph to identify the radius and center of a circle. To get us started with this, we're going to take a look at some Sketchpad circles and discover this equation to circles. So let me center this a little bit here. Okay, so if we're looking at this, we have our circle. I've already drawn this one in, and I'm going to go ahead and just pull up the equation for the circle. So this equation of this circle is x minus 4 squared plus y minus 4 squared, and that's equal to 3 squared. Well, let's go ahead and draw another circle, because there's definitely some relationship to these different numbers that we're getting. So I just drew a circle with radius 2, and if you notice, the center of the circle is located at -5, 5. So let's go ahead and take a look at this equation. This equation is x plus 5 squared plus y minus 5 squared equals 2 squared. All right, well, let's compare that to what we just had before. This circle had a radius of 3, so I can count the units from the center of the circle to the side of the circle. That's 3. And then our center is located at +4, +4. So it looks like from this that these numbers inside the parentheses with x and y have to do with the center of the circle, and the radius has to do with what this squared term is on the right-hand side. We can try one more, and this time I'll make one which is radius of 1, and this one's located at -3, 0. So now when I go ahead and to get the equation of the circle, this says that x plus 3 squared plus y squared equals 1. Well, at this point, what I want you to do is just think about the different relationships we have here and come up with what you think the general equation for a circle is. So if we were to make an equation of any circle, what would it be? And to test that, I want you to come up with the equation of the circle that we'd get. That's this one right here. So my center of this one is at 1, 2, 3, 4, -2. So my center is at 4, -2. And my radius is 2. So think about what the equation of this circle would be using your idea of what a circle is right now. Okay. So by now, we should know what the equation is going to be. We have our guess down, and we're going to check it. This is the equation. X minus 4 squared plus y plus 2 squared equals 2 squared. So if you got it, congratulations. It seems like you have an idea. If not, we'll work a little bit more with it next time in class, but we're going to go ahead and move on, and I'll give you that equation of the circle and see how we can use that. So our equation of a circle is going to be given by x minus h squared plus y minus k squared equals r squared. And this is where hk is going to be the center of our circle. So you should have noticed from the Sketchpad activity that this center was always going to be negative or opposite of whatever value the x and y coordinates were for the center. And then this number that was on the right side of the equation is going to be the radius squared. Sometimes we'll see that simplified, sometimes you might see it in this form. So the equation of the circle, if we had to do the one that was right here, we would say, okay, well my center here is at, it looks like it's at 1, 3. So if my center is at 1, 3, and my radius appears to be 3, we would say that this is going to be x minus 1 squared plus y minus 3 squared is equal to 3 squared. And we can simplify this so that it become x minus 1 squared plus y minus 3 squared equals 9. And this is usually what you write as the equation of the circle. Let's go ahead and practice one more of these. Here it's asking us to write the equation of the circle with the center 3, 4, and a radius of 6. Well, to get started, it's usually a good idea to write down the general equation for a circle. which is the following. X minus h squared plus y minus k squared equals r squared. Looking at this, we can label this is our h, this is our k, and this is our r. From that, we can just go ahead to substitute these values in. So I'm going to say x minus, my h was 3 squared, plus y minus, my k was 4, equals, my radius is 6, so I'll say 6 squared. The only thing that you might want to simplify is this radius squared. So I will write my final equation of this circle as x minus 3 squared plus y minus 4 squared is equal to 36. And we're done. A couple more examples and different things that we can do with this. So before we were writing the equation of the circle, now we should be able to graph the circle if we're given something. So if we're given this equation of a circle, we know that the two key pieces of the circle are the radius and the center. So it's a good idea to write down on the side these two pieces before you end up graphing it. If my equation of my circle is x minus h squared plus y minus k squared equals radius squared, then I can pick out the pieces of the circle that I need. So this piece right here is going to be my h. This piece right here is going to be my k. And then my radius squared will be equal to 16. And these are three little mini equations that you can use to solve to figure out those pieces. So if I said that h is equal to 3, I'm good there, that's solved. I can say k is equal to, well, this is not in the right form. K is equal to -1 when I solve this. It's the opposite of what's there. And then r squared is equal to 16. So that means that r is equal to 4. So our center is at 3, -1. I'm just taking the opposite of what you see in here. So +3, -1, and my radius is 4. I'm going to start by graphing my center. So 1, 2, 3, over, down 1. And for our radius, I know that it's going to be 4 above it, 4 to the right of it, 4 below it, and 4 to the left of it. And then from there, just try your best to get your circle drawn. And that's your circle graphed. Sometimes you might have application questions with circles, so those real world examples. So here we're skydiving, and a skydiving instruction school has a field with multiple landing targets. Each target is circle-shaped. A coordinate plane is used to arrange the targets in the field, with the corner of the field as the origin. The equation x minus 8 squared plus y minus 4 squared equals 9 represents one of those targets. We're asked to graph the landing target. So once again, this is like our first part. We know, looking at this, that my center is going to be at 8, 4, which is just the opposite of what's in here, and my radius is going to be at the square root of whatever this is, which is 3. So graphing this, I can go 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3, 4. So this point right here is going to be my center. And then to graph my circle, I'm going to need to go up 1, 2, 3, to the left 3, and to the right 3, and down 3. And there's my circle. So part A is completed. The next part says that the landing spots by the following skydivers are located as follows. So we have somebody, Marika. She's at 7, 3. 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3. So this is Marika. Alex is at 3, 4. 1, 2, 3. 1, 2, 3, 4. Julia is at 10, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 7. J for Julia. And Caleb is at 9, 6. So looking at this, which skydivers landed on target? And there's only 2 of them that appeared to have landed on target, which would be Caleb and Marika. We can say Caleb and Marika landed on target. Because Alex is outside of this, and so is Julia. We can talk about more precise ways other than just estimating if they landed on target or not in class. That's it for now, so we'll wrap up with a joke. What is a caterpillar afraid of? Well, caterpillar's afraid of a dogapillar